Thank you for participating today. I think it's quite interesting what we are going to present together. Together is me, Reinhard from MyPV in Austria, and with me is Matteo from Legrand in Italy. And together we want to show you the combination of our brands. We want to show you what you can do with a Legrand meter together with a MyPV device, and what benefits you have when you bring these brands together. Our topic at MyPV is about hot water heating from PV panels. So we are using solar electric power. We are not talking about conventional solar thermal power. This is what we have done in the past, but MyPV is offering solar electric solutions for more than 10 years now. And in changing the technology to wires instead of pipes, we make solar heating many times easier to install. And for many years, we already do it cheaper than conventional thermal piping technology. Okay, I would like to introduce our company at the beginning. As I said, my name is Reinhard. I'm at MyPV for 8 years now, and I'm responsible for product management. The other man I have to introduce, there is Dr. Gerhard Rimpler, which is our managing director on the left, and he's actually the mastermind of our solutions. We are a manufacturer and a developer of power electronics. With MyPV devices, you are able to adjust the thermal power output on an electric heating element linearly. So an immersion heater or an infrared panel is no longer just switched on and off. Now the power output is adjusted linearly. And this is essential to power it from PV panels because the solar electric yield is changing permanently from 1 second to the other. The other guy I have to introduce is my colleague Talal. Talal is responsible for international sales, and he's your direct contact for sales questions. Unfortunately, he's on a fair right now, so he is not with us in the webinar room. But I think about handling questions from your side by myself. I ask for patience, and if you enter a question on the right side of the screen in this chat panel, Matteo and me, we are probably dealing with it after the session. So if there are some misunderstandings or you need more detailed information in between, just enter your question in the chat. Yeah, MyPV's history is pretty young. We were founded in the year 2011, and we started our timeline as a manufacturer in the year 2013. So 11 years ago, and the whole story began with a product named ELVA. ELVA is an abbreviation. It just means electric water heater. And ELVA was and is the only DC solution from MyPV. All the other products that we are focusing on today are AC products, and these are the products that can be combined with a power meter from Legrand. All right, last milestone in our history was the expansion of our facility. So while we create solar electric building, Matteo, is there some noise at your end, or can you switch on the mic, please?
Yes, if you want, I switch off my mic.
Yeah, please temporarily switch it off because there is some noise on my speakers. Okay, thanks a lot. What I wanted to say, so this building here is a purely solar electric building. We built it in the year 2021, and it already has become too small for us. Last year, we increased our production area by a factor of 3. So the hall here in the background is actually the place where our manufacturing is now located, because last year we increased our production output by a factor of 20, the area increased by a factor of 3. And this was really necessary because with the Ukrainian crisis, the demand for autonomous solar electric heating solution, it went through the ceiling immediately. And last year we put all our power into this expansion of our production capacities. All right, Matteo, now I'm switching on my mic.
Okay. So, hello everybody. I see that there are a lot of IME customers in this webinar. So it will be for you, it will be something you already know what I will say. So probably the most interesting part will be what Reinhard has explained and will explain to you. In any case, for the others, it will be interesting to get to know IME, Biticino, and also our energy meters range. So let's start with a little bit of history. So IME was actually a family company, Italian family company, founded in Milan just after the Second World War. It became a supplier during the 90s of both Legrand and Biticino. For your information, Biticino was acquired by Legrand in 1989. Then in 2015, IME was acquired by Biticino. And in 2018, IME stopped to exist as company, but obviously remained as a brand and more in detail, the specialist brand of electrical metering devices within the Legrand and Biticino portfolio. For your information, to give you an idea of the size of the catalog of IME, we have more than 9,000 items inside our offer. Another change, which is also important, is about the fact that the IME historical site in Corsico, which is practically at the doors of Milan, was closed after the COVID in 2021, and the production was moved to the Biticino Erba site. The Biticino Erba site is near Como, is a center of competence for electronics in the Legrand group. In fact, in this site, we produced metering now, but also since several years, door entry system, home automation, smart home devices, and also UPS. As you can see in the slide, there are a lot of people working in this site and working for this site, and we manage really thousands of components, and we really mount each year millions of them. In our facility in Erba, there are highly technological processes for, let's say, generating the electronic boards, and also for testing that the electronic boards work properly. Of course, other functions within that were in Corsico have been moved in Varese, where I am today, where that is, let's say, the historical headquarters of Biticino. Speaking about Biticino, Biticino is a company within the Legrand Group that is market leader in electrical and digital infrastructure in Italy, the Italian market, with a turnover of about 900 million euros, of which 1/3 is export outside Italy. We have a lot of sites in Italy, 9 production sites and 1 logistic hub. You can see that our industrial production has increased a lot, and our, let's say, stakeholders, our value chain is really complex, with a lot of suppliers, thousands and thousands of electrical contractors, and tens or hundreds of distributors. So we have an international presence in almost 200 countries, and we are market leaders in at least one product range in more than 20 geographies. Our focus, obviously, is to be always ahead of competition. That's why we invest around 6% of our sales, of our turnover, on R&D. I leave to you now, Reinhard.
Thank you very much for the introduction, Matteo. We are going to hear more about IME meters after my session. And now it's about me to introduce hot water and power to heat solutions from MyPV. So we came to the idea or the understanding a long time ago that photovoltaic power can be used for much more than just delivering electricity. So in an on-grid systems, it's just normal that you directly use the energy for your light, for your appliances, for your household devices. That's clear. And what we see on the roads today is that also the EV segment becomes more and more important. Where MyPV is active and what we are dealing with is power to heat. So we now think about using surplus and excess photovoltaic power for applications like hot water heating or electrical space heating. Power to heat for residential applications. This is what we are doing. Some of our products are equipped with an immersion heater. And when people see an immersion heater with a heating rod like this, they think about this principle here on the top. They think that we are using energy from the public grid one by one to heat the hot water. Luckily, this is not what we are doing. This would not be sustainable. This would not be cheap. It would not be wise. What we are doing with our power electronics is adjusting the power output on an immersion heater like this. And in that way, we can use power from the PV because this PV power is changing permanently. Clouds are moving on the sky and the irradiation of the solar energy changes. And we are adjusting the thermal heating output here accordingly. So we are using energy from the sun. This is a completely different principle than this old stuff here from the top. And for all MyPV solution, there's an option that is called boost backup. So it's possible to use power from the battery or the public grid for the backup, if you like. So for days where there was not enough solar power available, I'm thinking about bad weather conditions or during winter time, you can choose the option to do the backup with power from the grid. Our factory preset is that this option is always deactivated. So when our products leave the production site, they are adjusted in a way that they only use excessive power. What is excessive power? It is power that would be fed into the power grid. But we want to keep it in-house. And this is possible with a MyPV device. So it's about using a new storage for your PV power. Most people are familiar with stationary battery systems. And in a single family house, we see storage capacities in the batteries of around about 5 kilowatt hours to 10 kilowatt hours. I'm talking about the single family home here. And this becomes more and more popular. Luckily, we need this kind of energy storage for the transition to renewable energies. We see another option at MyPV. We see the hot water boiler or the storage tank as another application for excessive power. And see there, if you heat up the hot water volume of a 300-liter boiler, let's say for 45 degrees centigrade, then we can use 15 kilowatt hours of your own produced solar electric energy. And this is times more capacity, of course, and this capacity is already there. It's already there where people living in residential buildings, and we can make use of this storage capacity. So there are two ways to think about this idea. Number one, we can be a cheap alternative to stationary batteries. That's clear for all the people who cannot yet afford a battery. We are the alternative to increase the self-consumption ratio, because the boiler is already there, and with the MyPV technology, it's quite cheap to make use of this capacity. The other way to see MyPV products is that we can be a cheap way to expand your storage capacity. So we can also be used in combination with a battery. It does not matter to us. We do not compete with stationary battery systems. And when you have an IME meter in your feed-in point, we just change one little setting, and then the battery has priority before our application, because once we have made heat out of the excessive power, we cannot take back electricity from the boiler. We cannot reverse the laws of physics, that's clear. And when there is a battery, priority is usually on the charging of the battery. Actually, there's one exception for this rule. For the Spanish market, I know that the hot water heating needs to be prioritized before the using of the energy in the household. This is a special regulation for Spain, but actually from thermodynamics point of view and from an economics point of view, electric energy has the higher value than heat. So usually priority is on charging of the battery. Why does it make sense not to feed into the power grid? Maybe you have a feed-in tariff that is not attractive. Maybe you get less money for feeding into the grid than you have to pay for, let's say, for gas. And then it's immediately interesting not to feed into the grid, but using this kilowatt hour of energy for heating. You replace the gas one by one immediately, and then you have an economics saving, a monetary saving here. And then it's about energy independence. We always have had the customer group at MyPV who were interested in a maximum of independency. And with the war in Ukraine, the number of those people has become bigger and bigger, because now we are all aware where we get the gas from, the natural gas. And this is a very strong motivation for buying a MyPV solution. And number three, I would like to show you just 3 of the 6, is a technical reason not to feed into the power grid. Because currently, for example, here in Austria, where I'm living, we are now using all the residential roofs that we can have. So everyone is right now building his own private PV system, but this already leads to bottlenecks in the power grid. And to avoid the shutdown of your PV system, it's wise to use all storage capacities for electricity that we have. The stationary battery is one option. Thermal tanks and hot water boilers are the other option. All right. So there are 2 solutions from MyPV that can receive the meter signal from an IME meter. To be complete, this is our ELVA solution. It's the only DC solution we have. And if you're interested in a solution like this, you can directly connect your PV panels to this immersion heater. There is no inverter in between, and now you're really autonomous. So it also works during grid blackouts, and you do not even need a permission from the grid operator. So enough on ELVA. Now we want to concentrate on AC products, because there IME comes into the game. There are 2 options. Number 1 is a product named AC ELVA 2. It's a power controller, and the power controller is combined in one product with an immersion heater. So you have an all-in-one solution. The immersion heater, the heating rod, comes together with the power controller for the heating rod. And this is this has an advantage for all projects where the end customer does not yet have an immersion heater in his tank. So it's quite attractive to make an offer with this combined solution. And the other option is a product named Actor. And Actor is a power controller, just as AC ELVA 2, but without an immersion heater. And this means you have the advantage here that you can also retrofit existing immersion heaters. So standard immersion heaters that normally are just switched on and off, and heaters that are not really smart and PV ready in that way, they can be made smart later on by an actor. I'm an engineer, so I'm often calling it a gearbox. The actor is a gearbox that you connect in between your AC building installation and the immersion heater, and now the immersion heater is linearly power controlled. And both products are linear power controllers, but AC Alba 2 comes with an immersion heater, and with the actor you have the option to retrofit direct electric heating elements, so ohmic loads later on. What is an ohmic load? It's an immersion heater, it's an infrared panel, or an electric heating mat. So also space heating can be made PV ready here. All right, so where does the energy comes from? It comes from the PV system. That's clear. First application is for direct electric appliances in the building, the washing machine, the dishwasher, and so on. This has priority by the laws of physics. And then priority is on the battery, if there is a battery. It's not required when you combine MyPV with IME, it's an option. So both ways are possible. If there is a battery, once again, the charging of the battery has priority before our application. But if there is no other way to use the electric power, we make use of it for heating before the energy goes back into the power grid. And AC Alba 2 is a newer generation of a product named AC Alba E. It's on the market for approximately half a year now. And here I would like to explain why it is so essential to control the thermal power output linearly. Because in a residential building or in an on-grid PV system, there are two things that are changing permanently. Number one is the PV output. It's clear why this is changing. The clouds are moving on the sky and the irradiation from the sun is not constant. The other thing that is changing permanently is the demand of power in the building. So the electric loads, something is always switched on and off and on and off. And what we make use of is just the surplus. It's just the excessive power. It's just the energy that would be fed back into the power grid. And to detect this surplus, it needs a metering in the feed-in point next to the utility meter of the energy supplier. And this is the place where the IME meter is installed. It's then giving us the excess power information to an AC Alba 2 or an actor via an RS485 communication. So it's Modbus RTU that we are using to communicate with an IME meter. And when you just switch on the light in the living room here, we immediately reduce the power output on the heater, because it's just about the excessive power. It's just about the balance in the feed-in point. And the linear power output can be changed from 0 to 3,500 watts. So AC Alba 2 has a nominal maximum power output of 3.5 kilowatts. And from 3.5 kilowatts down to 0, every single watt here is possible thanks to the MyPV power electronics in the device. So it's adjusting the balance in the feed-in point 1 time per second, very fast and very accurate. All right. Compared to the older generation, it has 4 major benefits. It has now more power output, and more power output means more self-consumption ratio and more autarkic rate. Then there's a graphic user interface. There's a color touch screen, which makes the commissioning very easy. You have the option to communicate additionally to the RS485 bus with IME, either via LAN or Wi-Fi. And when you connect it to your local area network, you can also make use of a web interface that is integrated in the device. And you can also connect the AC Alba 2 to the MyPV cloud, which gives you remote access to the device also from outside the local area network. And then AC Alba 2 comes in two parts when you take it out from the box. Actually, there's the immersion heater here separated from the power controller. And this makes it quite easy to install on site because the plumber is assembling the heating rod. He's doing the sealing and he checks whether it's leaking or not. And usually it's about the electrician who connects the power stage then with this electric box here with the display. And normally also the electrician makes the connection to the IME meter for the communication. All right. Here is the bottom view where you see the RS485 connection to IME. There is also the LAN connection, which is recommended to have remote access to the device. This is a slide with all the technical details of AC Alba 2. I'm giving the slides after the presentation to you. I'm sending it via email. I would like to skip all those details here because of time reasons. The only thing I want to mention is the way MyPV is adjusting the power output. We are regularly asked, do you have thyristor controllers or do you use phase angle control to adjust the power output? No, this is not how we are working. We have a pure sinusoidal power output. Actually, it works like a PV inverter does, and there is no thyristor in our device. All right, there is also an online calculator on our website. So to have an idea or to get an idea about the possibilities, you can check it. You do not even need to register yourself. It's free, available on our website. And here you can choose a MyPV setup. You can also check your project on an economic term because the operational costs can be taken into account when you adjust the price for your conventional heat. And you also can adjust the feed-in tariff here and then electricity rate for the energy consumption. I really want to recommend this tool to you. It gives you an idea about the possibilities here. And it's quite a good sales tool as well. So it helps you with your argumentation when you do energy consulting or sales activity. All right, the other power stage is the actor. And once again, there is no immersion heater on the actor. The power stage is now separated and it comes alone, and it gives you the benefit that you can use any direct electric heating element you want. The actor in a single phase variant is able to adjust the power output linearly from 0 to 3 kilowatts. And there is also a 3-phase 9 kilowatt solution to adjust the power output from 0 to up to 9 kilowatts. So also for 3-phase immersion heaters, it's possible to do the power control linearly. Both variants of Actor come with 7 predefined operation modes. These are more or less standard modes. The most common one by far is mode 1, the hot water mode. And this means that there is an immersion heater connected to the Actor. This immersion heater can either be assembled in a hot water boiler or in a storage tank. It does not matter. And here we also see how you connect the Actor to the IME meter. And once again, we always recommend to use Ethernet as well to have remote access to our device. One important detail, we recommend to terminate the Modbus with a 120 ohm resistor. And while there is this resistor is not included in the scope of supply of Actor, it is included in the scope of supply of AC Elva 2. That's the difference. Please be aware. We recommend this resistor, and we also recommend to use a shielded twisted pair cable. It also should be considered that the shield of the cable should be connected to earth, to ground, on one of both ends to have a stable communication with IME. All right. Here are the two options to choose IME as a signal source. The easiest way for both products, for AC Elva 2 and for Actor, is to do this on the color touch display. You just point on this line here, and then it's completely predefined that the devices connect to each other. And if you have LAN access or Wi-Fi access as well, you can also do this setting here in the web setup. All right. Yeah, here are the technical details for your info later on. Again, Actor is linearly power controlled up to 3 kilowatts. And here are also links integrated for your research. You can find datasheet, operation manual, and assembly instruction directly on this link. The same for Actor 9S within the 9 kilowatt variant. There is just one detail I really need to mention because it's important when you think about retrofitting an existing system. When you use an old existing immersion heater, please be aware of one detail. We always require a neutral conductor. So the Actor 9S is connected to the load in a star connection. It does not work in delta connection, unfortunately. Very important detail you need to know. There are also accessory parts from MyPV. So these are standard immersion heater that can be used together with the Actor, a 3 kilowatt single phase immersion heater and a 3-phase 9 kilowatt immersion heater for the Actor 9S, if you like. So, yeah, there are a lot of benefits, but I'm really focusing on time now because Matteo needs also time to show his devices. One last information I need to give is where you can find a short quick start guide for the combination. It's a 2-page instruction manual. You find it directly here with this link, and of course anytime also on our website available for download. And here you see in every detail how you have to do the wiring to combine MyPV with IME. All right, Matteo, you have temporarily dropped out of the webinar room. I hope the line is now stable once again.
Actually, it's incredible that happens during a webinar, but my PC crashed, so I'm using actually the mobile phone. Can you hear me fine?
Yes, perfectly.
Okay.
Can you move on with the slides, or should I do the clicking for you?
But I will try later after commenting the slide.
Okay. Otherwise, just give me a hint, and I'm available for your help. Okay.
Perfect, Rainer. Thank you. So this slide basically shows the range of IME. So basically, we have more dated devices like analog and digital meters that are still selling for some applications, but we are not clearly investing money on the development of these devices. Then we have our range of a big range of low voltage transformers. So basically it's current and voltage transformers. We have also Rogowski technology. So this part of the catalog is really rich. Then there is the part of let's say instruments, electronic instruments. So we have the energy meters that I will deepen in the following slides. We have multifunction meters that are instruments more sophisticated than energy meters because they give information. First of all, they are also panel mounted. Then they give information also regarding power quality parameters. We have a range for protection, which is our earth leakage relays range, and then we have also a range more for industrial automation, which is our transducers range. Then we have a system, modular and scalable system that we call NEMO SX. Basically, this system permits not only to measure and meter, let's say, the electrical parameters, but also it permits to have alarms in the switchboard and also to automate the switchboard, in the sense that you can have the status of the circuit breaker if it is open, closed, or tripped, and you can also switch on or switch off circuit breakers with a specific module. Then in the bottom right part of this slide, we have our supervision range, which is based on the 3 kinds of web servers that through a web page and an IP address, you can go on a PC or on a tablet or on a mobile phone and check the consumption with the histograms and make benchmarks and check the status also of the breakers. So this is basically our whole range. So I can change the slide, Reinhard. Okay, so these are our two launches, 2 last launches, the energy meters, of which I will speak to you in a minute, and the other one that have been launched in 2020. The other one is our last launch, dated 2021, which is a part of our multifunction meters range, which is called Easy Connect, because basically, as you saw in the picture, we have a quick connection between the sensors and the instrument, and also, as you see in the picture on the cover of the brochure, we have also the open Rogowski technology that permits really in a few seconds to install the sensor around the bar in the switchboard. So. Okay, so let's talk about now, let's focus on energy meters. As Reinhard very clearly explained, basically our energy meter can speak with the devices from IPV through a Modbus RTU communication. So our range of energy meter, basically, we have a 1 module DIN mounted single phase up to 45 ampere direct connection. We have also single phase 2 module direct connection up to 63 amp. Then we have we go to the 3 phase direct connection up to 63 amp, but in 4 DIN modules. And then we have also a reference that can stand a measure nominal current up to 125 ampere, 3 phase. In this case, it's 6 D modules. Then, of course, we have the indirect model, the one that accepts external current transformers. So this is the catalog page. So as you can see, we have MID and non-MID certified energy meters. We have, as I said, single phase, 3 phase, direct and indirect, and with external communication in Modbus or MBus, which is another communication protocol, or just a pulse output. Okay, speaking about the features of this energy meter. So clearly, in this kind of application, the bidirectionality is key. So we are able to measure both the produced and absorbed energy. So you will find basically a minus in front of produced energy. There is a very simple navigation with just the 2 push buttons that you see in the picture. In Modbus, there is the possibility to enable the 120 ohm termination resistor directly from the setup. There is the possibility to receive and store pulse from a third-party gas or water meter, and view this consumption of gas or water on the display, or also remotely via Modbus. In alternative, the inputs can be used also for tariff change, as we have embedded also double tariff input. As you can see in the bottom part of this slide, a very important feature for several applications, for example, like electrical vehicle charging station, is the operating temperature up to 70 degrees Celsius, this for the MID version. So the MID, an important thing is the MID certification permits in Europe, which is mandatory in Europe to have it, to re-invoice the energy. Okay, so we see now a focus of the graphical display, which is capable of displaying power and energy on the 4 quadrants. So the 4 quadrants would be active, reactive energy, plus or minus, so absorbed or produced energy. We have the current and voltage phase angle. This is very important to find, for example, a bud insertion. How? If you have more than 120 degrees of distortion, this means that you have a bad insertion of the voltages. Then, regarding navigation, with a long press of the setup button entering in the setup, it is possible to view all the parameters, such as, for instance, the Modbus address, that can be changed by entering a password that you will find in our documentation. Okay, speaking about MID version means that active energy parameter is compliant with the standard EN 50470 in class B. The no-mid version is in class 1, and according to the standard EN 62053. These two norms deal with the test condition of the energy meter. So the EN 50470 classify active energy in class A, B, or C. The EN 62053 is classified in class 1 or 2. The standard EN 61557 specify the requirements for power metering that measure and monitor the electrical quantities within an electrical distribution system, and defines the performance in single and three-phase system up to 1000 volt. So we can say this for the low voltage. This standard classify the different electrical parameters in several classes, like the precision class 0.5, 1, or 3. It's important to say that energy meters with an external current transformer, so an indirect energy meters, can be also used for medium voltage. So let's see more in detail the Conto D2, which is our single-phase energy meter. Current and voltage are in class 0.5. Active energy is in class 1 for the no-mid version, and in class B for the MID version. The neutral connector has the same size of the voltage connector, so you can use the same cable for the phases and for the neutral. In the upper part of the slide, you find the connector for the Modbus and DENBus or NBus communication protocols, and the pulse input and output, depending clearly on the model that you choose. For example, if you choose the item number CA2DF30PCL1, you have only the pulse output and the pulse input, or the tariff change. Depends how you want to use this input, for pulse or for tariff. You have the alternative. Okay, now we have a look to the three-phase. Here you see, so basically the Conto D4 with direct insertion, as I said, up to 63 ampere. The technical parameters are the same as the conto di 2, but in 3-phase clearly. All voltage connectors are on the bottom side for an easy installation. In the upper part, you find the connector for external connectivity, like in the conto di 2 that was explained before. And these connectors are detachable, meaning that an electrician can connect the bus without the energy meter directly installed on the bus. Okay, this is the conto D4 3-phase with current transformer insertion, so the indirect connection. Here also we have the maximum indication in 9-digit, but the difference with the direct model is that the number of the decimal part in energy value depend on the current transformer ratio. In fact, in case of direct connection, you have 2 decimal point and 7 for the unit part. Also here in the upper part, you find the connector for the connectivity for the Modbus or MBus protocols. Okay, now we speak just a few words about our range of low voltage transformers. So in particular, the current transformers. So the IME brand offers a complete range of current transformers covering measure, precision, so current transformers with a higher precision class, and protection typologies, and compliant to national and international standards, such as the EN 61869 1.2. So this standard in particular defines the condition of service, the nominal quantities, the design and construction, the evidence, the security, and the class and errors. Last slide from my side. Our current transformers are used to measure current up to 10,000 ampere. For all measure accuracy and protection transformers, we have a reference and isolation voltage of 0.72/3 kilovolt. And for special execution, we also reach 1.2/6 kilovolt. We have over 1,500 items in our low voltage transformer offer.
So,
okay, so Reinhard, I leave to you the word.
Thank you very much, Matteo. So if someone wants to have a power to heat solution for his building, there is quite a number of options from IME to do the excess power measurement. So very impressive. Thank you very much for this presentation.
Thank you.
So finally, it's about me to give you just a few more hints where you can find information. So regarding the MyPV side, there is always the download center on our website available, and you also find the IME Quick Start Guide for MyPV installation on the download section, and a few slides earlier you already had the direct link to this Quick Start Guide. There are also all the wiring diagrams for MyPV installations available anytime, so it's not necessary for the installer to wait until he gets the first delivery and check the assembly instruction to get an idea of the wiring. No, it's possible now every time to check the website and download all the wiring you might need to give you an earlier impression of the ways to install it. All right. Of course, YouTube also becomes much more and more important for us as a communication way. We are already also recording this webinar, and sometime during the next few days, the record of this session will be online as well. So if you want to hand it over to someone you know who is probably interested in the topic as well, there will be a record available later on for everybody. Okay, our products, your benefits. So what does it mean? For me, it's all about the very first advantage here. When you do power to heat in a residential building, you are using the very easiest way to increase the self-consumption ratio in an on-grid PV system, because once again, the storage capacities that we make use of are already there where people are living. And by using your own solar electric excess power for heating, it makes you quite a bit more independent from your utility or your energy supplier or energy imports in your country. Good. For me, this personal one is the most important advantage here. So where to buy? MyPV has a quite good distribution network in the German-speaking countries, Austria, Germany, and Switzerland. But in many other countries, there are already distributors who we are cooperating with. And just check our website to get an impression and then information whether there is already a MyPV distributor in your country or not. If not, I would recommend just to contact my colleague Talal or me directly. I will forward your email to him because you will have my contact data as well after the webinar now in a few minutes when I'm sending you the slides of the session today. Ladies and gentlemen, wherever you are, have a nice evening and all the best from my side here in Upper Austria. Thanks a lot.
Bye-bye. Thank you.
Empowering the solar future.